Hey everyone. We're gonna quickly go over a few things with this week's lab. So as you know, this week's lab is going to be observation, experiment, biostatistics, and there's a plethora of information found within your lab handout, which I suggest you read through. But we're not going to go over all those details. We're going to go over just the chi-square analysis, which you're going to need to know how to use and calculate for your lab exercise. So let's get started. All right, so the chi-square test. This is a statistical test used to analyze any differences that may be present between observed and theoretical values, which you'll see commonly referred to as expected values throughout this lab exercise. So what this statistical analysis is going to be looking at is it's going to be testing the null hypothesis, which states that the observed values that you received, that you collected from your experiment, is within a consistent range of their theoretical expectations. So also, it's important to note that these outcomes or the variables that you're going to receive are going to be categorical, stating that essentially a categorical variable is a defined result, right? So let's look at flipping a coin. Your results from flipping a coin is going to be categorical because you're either going to get heads or tails. You'll never get anything other than heads or tails. Or say for this lab exercise, you guys are going to be rolling a six-sided die, right? Even using a six-sided die is categorical because you will only receive values between 1 and 6. You'll never get anything lower. You'll never get anything more, which means that that experiment is going to have categorical outcomes. Your outcomes must also be mutually exclusive. And what that means essentially is that the probability of you obtaining two possible outcomes within your experiment simultaneously at the same time is going to be 0. So in the case of rolling your six-sided die, the probability that you are going to receive a 1 and a 2 in one roll is going to be 0 because you'll never, with a fair six-sided die, you should never be able to receive two values at the same time. And what we have here at the bottom is our equation. So chi-square is going to equal the summation of your observed value minus your expected value squared divided by your expected value. All right, so like you've seen in the lab handout, for this lab exercise, you're going to be performing two experiments, and they are both very straightforward experiments, where the first one, you're going to have a six-sided die, and you're going to roll it 100 times, and you're going to record which value you get throughout your 100 rolls. And for the second experiment, you're going to have a deck of cards. You're going to take out your two jokers, and then you will pull a card from that deck 100 times, each time replacing the card back to the deck and shuffling. So yeah, very straightforward experiments. If you're like me and you don't have a deck of cards or random dice laying around, then no worries. There are tons of resources on the internet you can use. Just Google deck of cards simulator, dice simulator. You should be able to find something real quick. I just looked through the App Store on my phone. I have an Apple, so looked through the App Store, and I was able to find both a deck of cards app and a dice app. So you should be able to perform this lab pretty easily. All right, so for my example, this is going to help out as well with your lab report. I also did a little simulation with a six-sided die, but I only did 50 rolls. So you'll have to do a few more for yours. You'll get some different different values, but you should be relatively in the same ballpark. So that can give you some type of idea when you're looking at this, what you should expect with your 100. But just know that you're going to be doing 100 rolls and not 50. So your numbers are going to be a little different. So the very first thing you want to do with your experiment is you are going to want to establish your null and your alternative hypothesis. So the null hypothesis, which you'll read in the handout as well, is just the hypothesis suggesting that nothing interesting is happening within your system that you're studying. Or in other words, your expected values is going to equal your observed values. So the amount of values that you record during your experiment should equal the values that you expect to receive in your experiment. And your alternative hypothesis is going to state that your expected values do not equal your observed values. And really that is all the detail that is needed within your experiment. So you're also going to provide this within your lab handout where you're going to establish your null and alternative hypothesis. So it should be exactly this, what I have in front of you. Pretty easy. All right. So for this example, like we said, I had done 50 rolls of a 6-sided die. Here I have it set up my categories, listing my 6 sides, and here are the values that I got out of my total of 50 rolls, how they were spread out throughout my experiment. So your expected, when you are going to be, like I said, you're going to need to calculate your expected. It's not predetermined. So your expected is going to equal the probability of the observation divided by the total number of observations. So for example, let's look at the probability of rolling a 6 or rolling a 1 in your 6-sided die. It's going to equal 1/6 because there's 6 sides. Each possibility of rolling each side is equal, so it's going to be 1/6. So to calculate your expected, you'll take that probability, right, 1/6, and times it by your total number of rolls, or your total number of observations, and that's going to equal 8.33. And since this is a fair die, each side has an equal chance of being rolled. All my values are going to equal, all my expected values are going to equal 8.33. And from there, I can continue with the equation, and as you saw, the top is going to equal observed minus the expected squared. So I went through and calculated like this, and this chart here you can definitely utilize for your lab report. I think it will make calculating your chi-square value a little easier. So I did this, and then you divide it by your expected. You'll get some value here, and then you will add all those values, and your chi-square value is going to equal the summation of all your values. And for my experiment, it is 5.4. So the next part of the experiment, after you've already calculated your chi-square value, also referred to as your test statistic many times. So after you completed that, you're going to need to determine what your critical value is. And to determine your critical value, you're going to need to know your level of significance and your degrees of freedom. And the level of significance is something that's predetermined. Generally, conventionally, your level of significance is 0.05. And this is something you'll learn about in biostats, so we're not going to really go too deep on explaining what level of significance means. But your degree of freedom is going to be determined, and all your degree of freedom is your categories minus 1. So in our case, and yours too, for the 6-sided die experiment, as we have 6 sides of our die, right? We have 6 categories. 6 minus 1 is going to equal 5. So our degree of freedom is 5. And we already established that our level of significance is 0.05. So you'll go down that line, and for our degree of freedom, our critical value is going to be 11.07. All right, and the final part of performing the chi-square test is going to be drawing conclusions and interpreting your results. So in any case, you're going to, and in this case, I should say specifically for the experiment we have, you're going to reject the null hypothesis if the test statistic, which is what you calculated, is greater than your critical value, which we just determined on the previous slide. And you will fail to reject your null hypothesis if your test statistic is less than the critical value. And it's really important to notice that we did not say that we accept our null hypothesis because you don't have enough data to accept your null hypothesis. All you can do is fail to reject your null hypothesis with the current data that you have for your experiment. So in our case, and for this example, since we received 5.4 as our chi-square or test statistic, and that was a lower or less than 11.07, we failed to reject the null hypothesis and explain. So when you do your lab report, briefly state what that means. You don't have to write a paragraph. All you have to do is, in regards to your experiment, you rolling your 6-sided die, you calculating your observed and calculating your expected, same thing for your deck of cards. What does it mean when you fail to reject the null hypothesis? So it will sound something like, since we failed to reject the null hypothesis with the data that we have, our observed values is there's no statistical differences between our observed and our expected values. So something along those lines. You don't got to sound like some statistician or anything, but just briefly provide an explanation. And yeah, I think that's actually everything. So let me know if you have any further questions.